Today, we will be starting back with our mysterious and the most interesting topics, that is your interesting subject, chemistry. Last, in the revision portion, we had completed our chapter number 1, chemical reactions and equations. I hope in the previous month, you all must have opened your books at least once to see what all we have done. If not, I am confident that in the last week, you must have revised the chapter. Today, we will be starting off with the second chapter of NCERT, and that is acids, bases and salts. When I talk about salts, I hope many of you can have a clear picture of Desh ka namak, Tata namak. That is not the only salt present. We have very many salts in this chemical world. For example, you can further say, Madam Kala namak, Senda namak. But again, apart from those salts, we have various chemicals which are categorized under the salts. If I talk about acids, the household examples of acids that you all must be familiar with is citric acid, which is present in citrus fruits, lemons, oranges and all. Second one is the tartaric acid. Apart from them, we have a toilet cleaning acid in our home. That is also an acid, HCl, hydrochloric acid. We also use a combination of bases in our cooking, cleaning, digestive disorders. Example, we use baking soda and baking powder for making deliciously yummy cakes. Next, we use ENO or milk of magnesia for curing our digestive disorders. All these are categorized under bases. So let's just start with the definition and classify acids and bases separately. Long ago, there was a scientist named Arrhenius. He categorized acids and bases based on the evolution or release of H plus and OH minus ions. The substances which release H plus ions are acids, and those which release OH minus ions are bases. So according to Arrhenius, acids are those substances which release H plus ions, and this H plus is also known as a proton, which we will be using in our next class if you take the science stream. So acids are the substances which are releasing H plus ions when dissolved in water. Let's have an example of certain acids. H2SO4, HCl, HNO3 and acetic acid. If I talk about the name, this is sulfuric acid, hydrochloric acid, nitric acid, and this is acetic acid, which is also known as vinegar, which is a very common example for all the Chinese food lovers. Now if I talk about H2SO4, if I add it in water, the teacher or the lab assistants if there are any. Never try to open the bottles of acids just for the sake of fun use. The second property of acids is they turn blue litmus red. Be it red or blue litmus solution or blue litmus paper, acids will always turn the litmus paper into red. Let's see it with the help of a small experiment. So we have a strip of blue litmus paper, and as I told you that acids have the property to turn this blue litmus paper red. Now if I put a drop of acid on it, you can see the change. It is very clearly visible that the blue litmus paper is turning into red. Now again if we try to do that, we can have litmus solution also. This is acid and here I have the blue litmus solution. When I pour this blue litmus solution into the acid, it is very clearly visible that it is turning into red. So you can see that the acid has turned the blue litmus solution to red. So this was the next property. Now if we talk about another property of acids is that they are sour in taste. Be it orange juice or lemons, whenever we have them, whenever we consume them, there is a bit of tangy taste or there is a bit of sour taste in that. So we can say that acids turn blue litmus red. The next one is acids have sour taste. Now we move on to the chemical properties of acids, and the first chemical property we have already seen in the previous chapter, that is neutralization. Now neutralization, we can also say that it is reaction with base. Whenever an acid reacts with a base, salt and water are formed. This is neutralization reaction. That is acid plus base gives salt plus water. Let's have certain examples. Suppose we have HCl and for base we have sodium hydroxide. They will form salt and water. In the previous chapter I have told you that whenever you write a chemical equation, always mention the names of the reactants and the products just beneath the formulas. So this is hydrochloric acid when reacted with sodium hydroxide, it will form sodium chloride and water. The second chemical property which we will study after the neutralization reaction is the reaction of acids with metal carbonates. The next we have reaction with metal carbonates. Carbonates have the general formula of CO3 Na2CO3. So sodium carbonate is Na2CO3. Now let's just have a small experiment. I am taking sodium carbonate in a test tube, and now let's just add very few drops of acid and see what happens to this. This is sodium carbonate, and when I put acid into it, you can see these bubbles coming out. These bubbles are of the gas carbon dioxide. So one thing is very clear, that whenever a metal carbonate is reacted with acids, CO2 gas is released, and the things which are formed are metal salts, water and carbon dioxide. So if you write it in the form of formula or an equation, it is acids, any acid, plus the metal carbonates. This is the generalized equation which is applicable for all sorts of metal and acids and all sorts of metal carbonates. Will give us the salt of the metal, that is metal salt or metallic salt, plus water will be formed along with the evolution of carbon dioxide gas in the form of brisk effervescence. Brisk effervescence are the strongly coming out bubbles. Now I just want to show you a small thing. This is a very small amount of acid which I have taken, that is just few drops. Now if we are in a playful mood in the laboratory and we take a large amount of metal carbonate, you can just see that a very large amount of effervescence will be evolved, and this can be dangerous for us. See the amount of effervescence which is evolved. This can be dangerous. The acid can come on us, the effervescence can come on us. So it is very important to be very cautious while doing these practicals in the lab. Let's just have a small equation. Suppose we have hydrochloric acid and we have sodium carbonate, that is Na2CO3. We have already seen that a metal salt will be formed. Metal salt, that is we have NaCl plus we will have water, and carbon dioxide gas will be released in the form of brisk effervescence. We need to write the names beneath the acids and the bases in the chemical equation. Now let's just see another equation where, or the third property, where metals carbonates. Now we see metal bicarbonates. In class 9, you all must have learned a table for valencies, and there it is that bicarbonates have the general formula HCO3 minus. So metal carbonates will have MHCO3 minus 1. So sodium, and this is bicarbonate, plus 1 minus 1. The formula will be NaHCO3. This is sodium bicarbonate, and it also has one more name, and that is sodium hydrogen carbonate. That is sodium bicarbonate is also known as sodium sodium hydrogen carbonate or sodium bicarbonate in a boiling tube, and now I will add concentrated hydrochloric acid into it. Just see the tendency of the effervescence evolve. So if we are taking the salt in a large quantity and adding acid in a large quantity, a great amount of effervescence is evolved. It can also come outside the boiling tube, so be very cautious while performing this experiment. This effervescence are again of the same gas, that is carbon dioxide. So the third property, that is reaction of acids with metal bicarbonates. We'll have the same thing, acid plus metal bicarbonate or metal hydrogen carbonate will give the same thing, that is the salt of the metal, that is the metallic salt, along with water and carbon dioxide gas will be released. We'll just see the example which we have taken. We have taken hydrochloric acid, we have taken sodium bicarbonate, that is NaHCO3. So we'll have NaCl, that is sodium chloride, plus H2O plus CO2 gas is released. That is brisk effervescence of carbon dioxide gas. These are the three main chemical properties of the acids. In the next chapter, we'll study about bases, their physical and chemical properties.